living history lesson ties together the islands of New York City. Each bridge has a unique story to tell. From the East River to the Hudson, beneath the steel and stone, are tales of genius, courage, greed, and death. Our first story begins with a sea of humanity blanketing the Verrazano Narrows Bridge at the start of the New York City Marathon. Spanning New York's harbor, the bridge, built between 1959 and 1964, has represented a way out for the residents of Staten Island. For until 1964, Staten Island's only connections to New York City were the ferries that crossed between Staten Island, Brooklyn, and the island of Manhattan. The Verrazano Narrows Bridge gave the rural and isolated islanders their first land link to Brooklyn, but it was a mixed blessing. Overnight, Staten Island crawled with displaced Brooklynites looking for an affordable place to live.
There was a massive outmigration of not just middle class, but working class people. And that's what the Verrazano Bridge did. It allowed the Italian working class and lower middle class of Brooklyn an escape route to the suburbs. That escape route was the Verrazano Bridge, and the suburb was Staten Island.
A migration triggered by the chairman of the Triborough Bridge and Tunnel Authority, the politically powerful Robert Moses, builder of the 1964 World's Fair, Lincoln Center, and Shea Stadium. To create room for the Verrazano's substantial approach roads, Moses ousted 8,000 Brooklyn inhabitants from their homes.
In the 1930s, 40s, 50s, as roads were being built in New York, and we were building it before there was federal aid for roads, Bob Moses had the power of eminent domain as the city's construction coordinator. He can decide that it was in the public interest to take your house, to take your property. And there's very little that you could do other than go through the political process. He would have design drawings and engineers come out, and then you would have to move.
But nobody would think of ever bucking City Hall or Robert Moses.
Nor did anyone buck Moses when he nixed rapid transit, forcing everyone to travel the Verrazano by car.
You needed a car, which said you were from some kind of an economic class. So in many ways it polarized the city. And so designing a bridge the wrong way to not introduce transit created one community that was more affluent and more white, and that was the community of Staten Island, and it left Brooklyn to be more minority, a poorer community.
As he'd done before with his bridges, Robert Moses hired the now elderly master bridge builder Othmar Ammann. Critics charge that Ammann may have designed the bridge, but he designed Robert Moses' bridge. Costs spiraled quickly. At completion, the Verrazano cost over $320 million. Workers spent a year building the Verrazano's two towers. Built perpendicular to the Earth's surface, they are 1 5/8 inches farther apart at their tops than at their bases due to the curvature of the Earth. The 690-foot tall towers are higher than most of Manhattan's skyscrapers. From anchorage to anchorage, the structure extends 6,690 feet. The fantastic Verrazano flaunts a 4,260-foot center span and double-decked 6-lane roadway. Ammann said the bridge was conceived as an enormous object drawn as faintly as possible. Ed Fennell's father worked on the cables.
The younger, more crazy ironworkers would take their American Bridge hard hat, was like a bowl, and the cable was getting weaved like this, the main cable. And they would sit in their hard hat and slide down the cable to get to lunch.
It took 6 months for the crew to spin the 4 main cables that support the roadway, testing each wire for size, strength, and metallic content. Then the cables were carried from anchorage to anchorage on a wheel that laid them side by side and one above the other.
It's called the Eternal Wheel, and it was hung on a cable over where the main cable would lay, and it just ran 24 hours a day in the Verrazano Bridge.
In a suspension design, the parallel cables are the main support member. The cables are strung over towers that run the length of the bridge and are anchored at each end.
These are huge blocks, heavy blocks, and their purpose is to hold the cable, to resist the cable. And then you have the cable goes to the other end, to the other anchorage. And it's anchored in the anchorage. Typically, the cables would splay out into bands of wires, groups of wires that would wrap around I-bars, steel beams, that are then embedded in the cable, in the anchorage, and they're embedded further and further, and then you get to the very base of the anchorage, and there's a plate. It's attached to a plate. Now, on top of that plate is masonry and a very heavy block that resists that pull. So you've got the cable wanting to be pulled this way, and it's trying to lift this block up, and that's what holds it.
Suspenders hung from the main cables support the deck. It was the longest suspension bridge in the world and held that record until 1981. Named for the 16th century Italian explorer who discovered New York Harbor, the Verrazzano Narrows was dedicated on November 21st, 1964. When it came time to present Othmar Ammann, Robert Moses introduced the 85-year-old as the greatest living bridge engineer, perhaps the greatest of all time. Although Ammann is credited with many bridges, the Verrazzano Narrows was his consummate achievement. Coming up, a medieval symbol of New York City. The Verrazzano Narrows broke San Francisco's Golden Gate Bridge span record by 60 feet. New York bridges will return on Modern Marvels. East of Liberty Island, joining the island of Manhattan to Brooklyn, is the Brooklyn Bridge. After 13 years of construction, in the spring of 1883, New Yorkers marveled at their new bridge, framed against a sky brilliant with fireworks. Spanning the East River with its neo-Gothic towers and dense network of cables, the Brooklyn Bridge was the largest suspension bridge in the world. So impressive, New Yorkers compared it to the pyramids, and it hadn't opened for carriage traffic a minute too soon.
Manhattan had been practically nothing in 1800. By 1875, there were 1 million people on Manhattan Island. By 1910, there were going to be 2 million people. And they could see it coming. And they were desperate for space.
An East River Bridge could solve overcrowding on the island's Lower East Side and spur development of Brooklyn as well. A joint venture, it was originally called the New York and Brooklyn Bridge. After the city's consolidation in 1898, the New York name was dropped.
The Brooklyn Bridge cost an enormous amount of money to build at the time that it was constructed. It required the resources of a much larger city than just New York, the island of Manhattan at the time, or the city of Brooklyn at the time, and the two of them had to come together.
Before the Brooklyn Bridge, the only way to cross the unpredictable East River was by ferry.
And we may think they're romantic today because we don't have to depend on them. But believe me, when that was the only way you could cross the river, you hated them.
In 1865, over 41 million people crossed the East River by ferry, sandwiched on boats moving between Brooklyn and Manhattan. East River passengers were as likely to lose their lives as make their destination. One miserable commuter was legendary engineer John Augustus Roebling. Roebling pushed for a suspension bridge over the East River. As a famous bridge designer and owner of a wire rope company, Roebling wanted to build the bridge himself. His proposal was met with mixed reaction due to the fact that many of the turn-of-the-century bridges collapsed.
Along comes Roebling with a design for an almost 1,600-foot span, unthought of, unheard of. This is the moonshot of the mid-19th century.
What basically made the Brooklyn Bridge possible were improvements in wire technology. Much in the same way that improvements in elevator technology made it possible to build the skyscraper, they were able to come up with a wire that was strong enough to bridge the East River without snapping.
John Augustus Roebling's wire rope cable was the breakthrough in modern suspension bridge technology. In 1869, the same year the bridge's plan was approved, John Roebling died of tetanus. He would never see his cobweb of cables reach to the sky. The entire construction of the Brooklyn Bridge fell to his 32-year-old son, Washington. 1 year later, Washington Roebling ordered pneumatic caissons floated onto the East River and sunk into the riverbed. Inside these wooden subterranean chambers, immigrant labor paid $2.25 a day, mined for bedrock. They needed a firm foundation for the bridge's towers, which would stand in the river.
They would begin to put successive amounts of stone on top of the caissons, and this weight would push the caisson down.
Compressed air was pumped into the caissons to keep them from sinking into the mud. As the depth increased, so did the air pressure.
And then they would send the workers in there with shovels and picks and so forth, and they would literally start excavating all of the material that's in the caisson.
Workers entering and leaving through an airlock experienced excruciating pain. The changes in air pressure of the caissons proved deadly. Caissons disease, also known as the bends, killed 3 men and paralyzed others, including Washington Roebling.
They thought it had something to do with poor oxygen quality in the caissons. They thought that the men were in too cramped conditions. They even looked at the mud to make sure that there wasn't some kind of gaseous exhalation that the mud was giving off when they were doing the excavation work within the caissons.
Permanently unable to walk or talk from the crippling bends, Washington Roebling became known as the man in the window. He supervised the bridge from his townhouse in Brooklyn Heights, using Emily, his wife, as an intermediary.
It was dangerous, but it was work. And this was important to the immigrants. Now, they were paid very little. It went on strike, and actually I believe the strike was broken. Because after all, the bridge builders could always go out there and scoop up another bunch of immigrants.
Digging through the riverbed of loose mud, silt, and stones, the Brooklyn Foundation hit bedrock at 44 feet. The foundation on the Manhattan end rested on sand. A geologist as well as an engineer, Washington Roebling learned from his borings that in Manhattan, bedrock was about 175 feet below the riverbed. He'd reached about 78 feet. Roebling would not risk more men. So, after an analysis of the stratum from his boring, he determined that if the particular layer that the tower would be sitting on, which was compressed silt, had not moved in the past 100 million years, most likely it would never move. Roebling put an end to the excavation, finished construction of the towers, and began to lay the cables that held up the framework of the bridge.
A rope, a very thin line, would be shot across the East River, or hauled across the East River. And attached to this piece of rope was the first strand of wire, some of which is actually thinner in diameter than a human hair. And they would painstakingly pull the first of the wire strands across, hang them over the top of the towers, and affix them to the anchorages that sit on either end of the bridge and anchor the cables to the earth.
The cable was made up of a large number of individual wires which were parallel to one another. Neither the cables nor the wires were twisted in any way. Suspended from a board seat with ropes at its corners, men traveled between the towers on pulleys.
And then when they had a bundle of a couple of thousand or a few thousand of those strands, they would have a machine that came along that was like a large spinner. And it would basically pull the strands together and it would bind them.
They'd repeat the process until they had over a dozen bundles of wire. Then they would be bound into one large cable, which are the main cables seen on the bridge today.
It was the longest suspension bridge in the world. The wires on the bridge, steel wires with a coating of zinc, a galvanized coating, provided tremendous strength and also provided tremendous resistance to corrosion.
Each of the 4 steel cables could hold over 11,000 tons. It was determined in later years that the Brooklyn Bridge was 6 times stronger than necessary, for the time in which it was built. For everyday New Yorkers, the bridge's strength was every bit as important as its view.
The first great bridge had a promenade that was purposely centered in the middle of the bridge and raised above all the traffic and all of the barriers so that pedestrians would have the finest view. And indeed they did. John Roebling, designer of the Brooklyn Bridge, considered it a boulevard in the sky.
From the bridge, New Yorkers could glimpse their future as a world-class metropolis. Just north of the Brooklyn Bridge and the Manhattan Bridge is the mechanical-looking Williamsburg. Built because for all the hoopla, the Brooklyn Bridge just hadn't gotten the job done. Ferries were still packed in the 1890s, and New Yorkers were frantically lobbying for a second East River Bridge. It was logical that Manhattan be bridged to Williamsburg because Williamsburg was a bustling port and home to the super-rich owners of the companies based there. Under pressure, Chief Engineer Leffert L. Buck and architect Henry Hornbostel erected a suspension bridge in just 7 years, less than half the time it took to build the elder statesman Brooklyn Bridge.
The bridge goes back with my own history of my parents who were both immigrants from Europe who ended up on the Lower East Side. It's a very typical story. And they crossed the bridge, the big bridge to Brooklyn, and then lived in Williamsburg on the other end. And my mother even told me stories on very hot nights that they would go out and they would sleep on the bridge.
The steel-towered Williamsburg Bridge was begun in 1896 and opened with great fanfare in 1903. With a main span of 1,600 feet, it was the longest suspension bridge in the world, wrenching from the Brooklyn Bridge a title it held for 20 years.
One of the things that the Williamsburg Bridge did was give these poor residents of the Lower East Side, and by the time it opened and really got going, it was the Jews, it gave them an escape route across the river to Williamsburg, and they took it.
If you were poor, if you were working on the Lower East Side and you were living in Williamsburg, which was a common trip, that's how you got back and forth, and these bridges enabled you to do that. They cared for the poor.
Once the bridge was up, previous well-to-do citizens of Williamsburg fled. When the penniless foreigners arrived, 6-story tenements waited to house them. By 1910, Williamsburg had the densest population and highest infant mortality rate in all of the newly unified Greater New York. The Williamsburg became known as Jews Bridge because Jewish immigrants walked daily between their old neighborhood in Brooklyn and their new neighborhood in Williamsburg.
And walking was the major mode of transportation. So they built promenades. This is 16 feet wide. They had a second one on the other side of the bridge, 16 feet wide. 32 feet devoted to pedestrians, and the pedestrians filled every inch of it.
With its cumbersome lattice construction, the overall effect aesthetically was an ungainly mess. One unkind critic of the day, John DeWitt Warner, described it as the surrender of the city beautiful to the city vulgar.
This bridge is suspended, held up by just 4 cables. Each cable is 19 inches in diameter, has 7,696 parallel pencil-thin wires, and they spread out into 37 strands in the anchorage. Those strands, each strand is wrapped around an eye bar, which looks like the eye of a needle. And those eye bars are embedded in the concrete and masonry structure, which weighs 130,000 tons. So it's embedded in that. At the very bottom, there's a steel plate, and that's what resists the pull. The cable is pulling on those eye bars, which are then pulling on that plate, which is trying to lift up that 130,000-pound structure, and that's why this bridge stays in place.
But Leffert Buck cut corners with the Williamsburg's cables. By not using the process of galvanizing the wires, covering them with a zinc coating to resist corrosion, he ended up costing New York City a fortune.
They didn't protect that cable and galvanize the wires, so they put just pure, plain steel wires in that cable, and of course within a short amount of time, water got into the cable and began to corrode the cable.
Within 3 years of its opening, the Williamsburg Bridge needed strengthening and straightening. Years later, it was considered so unsafe, it was shut down. if little else it did what it set out to do, relieve the congestion on the Brooklyn Bridge. Next, a Jazz Age addition to the East River. In 1884, circus owner P.T. Barnum herded 21 elephants across the Brooklyn Bridge to test its strength. New York bridges will return on Modern Marvels. About a half-mile upstream on the East River from the Brooklyn Bridge is the Art Deco Manhattan Bridge, a second connection between Brooklyn and Manhattan. Its anchorages rest between Canal Street in Manhattan and Flatbush Avenue in Brooklyn. Erected between 1901 and 1909, this was the third of the East River suspension bridges to be built, and today is one of the most heavily traveled. The main span between the towers is 1,470 feet. Daily, 78,000 vehicles and 350,000 people use the bridge's 7 lanes and 2 subway tracks. The bridge's canal approach on the Lower East Side of Manhattan empties into the arms of this triumphal, although some consider grandiose, Beaux Arts arch and colonnade, designed by the architectural team of Carrere and Hastings.
The Manhattan end was called the Court of Honor. And the triumphal arch on the Manhattan end was modeled on the Porte Saint-Denis in Paris along the Grand Boulevards.
But the bridge that lay just beyond the arch sorely lacked the grace of its entrance.
When they created the Manhattan Bridge, which in scale and in usage is completely 20th century, the Manhattan Bridge was a heavy-duty urban bridge with a vehicle roadway, space for subways and L trains, trolleys, and of course a pedestrian walkway. At the Manhattan end and at the Brooklyn end, they wanted great triumphal arches, and they hired Carrere and Hastings, who did the public library on 42nd Street.
If you were to compare, say, the towers, the stone towers of the Brooklyn Bridge, which was opened in 1883, to the steel towers of the Manhattan Bridge, which was opened in 1909, you'll both notice that they are in a neo-Gothic style. But one is a much more earthly structure, the Brooklyn, with all of that handsome stone and the solidity and the affirmation that gives, whereas by the time 1909 comes about, you're in the midst of the cast iron age, in a sense. It is not a cast iron bridge, but its decoration, the way it's designed, is very reminiscent of cast iron architecture.
The all-steel bridge's ornamental detailing has long been of special interest to many. When building the Manhattan Bridge, once they'd completed stringing the cables, workers hung the suspender ropes.
These are what comes down and holds the girders, the stringers in place, so that you can actually start putting down the deck. And they would usually start around the towers. Once they had the cables in place, they had their platforms in place, they would start hanging the suspender ropes, and then they would put the stringers across, and they would start next to the towers and then start building outward on both sides. So that in a sense, the bridge grew from the outside in.
It was hard labor. It was very long days. They didn't have the ability to have mechanized equipment move heavy blocks, and so a lot of it was just blood, sweat, and tears.
Leon Moisheif created the 2-level Manhattan suspension bridge. While it looks light because of its color and delicate suspension cables, its strength can be measured in almost 100 years of service. North of the Williamsburg Bridge, arching the East River and crossing Roosevelt Island, is the Queensboro Bridge. Situated between 59th and Manhattan and Long Island City in Queens, and constructed between 1901 and 1909. It's the first major bridge in New York to depart from the cable suspension design, and a bridge so exciting to the public with its massive silver-painted trusses that when it opened, 235 people applied to jump from it, 130 feet into the East River. The applications were analyzed and broken down into professional high divers, freaks, would-be suicides, and the unemployed. Not one application was approved.
When the Queensboro was opened to service in 1909, you were coming out of the cowboy tradition of the West. It was very popular for people to go over Niagara Falls in a wooden barrel, and it would be very popular for people to leap off the Queensboro Bridge into the river.
Jumping from the center of the $20 million bridge would have landed the Daredevil on Roosevelt Island, where bridge designer Gustav Lindenthal's cantilever spans meet.
A suspension bridge is supported from above. A cantilevered bridge is supported, in this case, from a tower. It is supported from the tower, and there is a structure that allows it to go out in an L shape. So you have the tower, and then you have a structure above, a truss-type structure, that will allow that bridge to stand by itself without anything supporting it above and without anything supporting it below. So it's cantilevered.
Two anchor arms extend from opposite shores and are joined by a middle span which is supported by piers. The arms support the midsection by the force of tension. The piers absorb the downward force. The trusses are metal triangles that support the floor either above or below.
It was going to be designed to link Manhattan with Blackwell's Island, now known as Roosevelt Island, and Queens. And essentially they knew it was going to be for trains. And they knew that the suspension bridge was not the best form because of the fact that if you had trains moving across the span and they were not in tandem, the bridge would have a tendency to deflect. And so the trusses were considered much stronger for rail traffic.
The scheduled opening of the Queensboro was delayed when another cantilever span, the Quebec Bridge, which stretched across the St. Lawrence River, collapsed. The public was horrified. The Scientific American reported that dangerous changes had been made to designer Lindenthal's plan, and that the Queensboro Bridge could also fail. They called in experts to test the bridge's strength, and work continued on the bridge approaches. The Queensboro Bridge was redesigned and opened on March 30th, 1909. Despite Lindenthal's best efforts, the Queensboro Bridge is clumsy looking and its decorative features are out of place. Henry F. Hornbostel, the bridge's consulting architect, reportedly said when he first saw the finished bridge, "My God, it's a blacksmith's shop." For the citizenry of Queens, the 7,449-foot bridge was a fiscal windfall.
When they built the Queensboro Bridge, it was built literally into a rural county. There's a famous photograph of the Queensboro Bridge being built, taken from Long Island City, a rural Long Island City, and you are literally watching the city and the future coming to Queens County.
Real estate development spread fast. Farms were leveled, roads were paved, trolley lines from the Queens side of the bridge were laid to previously remote areas. Queens' population of 275,000 ran up to over 1 million residents by the 1930s. Today, the bridge formerly known as the Queensboro is called the 59th Street Bridge by locals, the same 59th Street Bridge made famous by Simon and Garfunkel. From the Queensboro Bridge, you can see impressive views of the Chrysler Building and the United Nations. But to get that view on foot, prepare to walk on metal grates that vibrate as the traffic thunders by. Next, the first span across the mighty Hudson River. The George Washington Bridge is the most heavily trafficked of all New York City's bridges, carrying 95.8 million cars a year. New York bridges will continue on Modern Marvels. It was a technological tour de force, this new bridge that crossed the Hudson River from northern Manhattan to Fort Lee, New Jersey. Begun in 1927 and dedicated in October of 1931, President Franklin D. Roosevelt called the $59 million George Washington Bridge almost superhuman in perfection.
What Ammann did with this bridge that made it so significant in engineering terms is he applied a new theory called the deflection theory. Basically, what the deflection theory said was that when you get a bridge of a certain length, its size is so big that the bridge itself can steady itself from the effects of moving traffic and wind.
Ammann reasoned that the stiffening trusses used to check the flexibility of earlier suspension bridges like the Manhattan that were designed for railroad traffic were not necessary on the GWB. The dead weight of the bridge deck, along with the 4 great cables, would be ample to withstand heavy wind. After the bridge's steel towers were sunken firmly into rock and concrete, the rope cables were strung from the anchorages. 2 spinning wheels, one at the anchorage site in Fort Lee, New Jersey, the other at the anchorage site in Manhattan, traveled back and forth, creating strands, then spun into one of 4 cables 3 feet in diameter, a mile long, strong enough to resist the pull of 1,000 locomotives. At completion, the GWB spanned almost twice the distance of its 19th century East River rival, the Brooklyn Bridge, making it the longest suspension bridge in the world, and another career achievement for its chief engineer, Othmar Ammann.
It almost doubled the length of any previous bridge in terms of its span. It's 3,500 feet long between the towers, which is the equivalent of 15 city blocks. It's like Madison Avenue between 42nd Street and 57th Street, elevated 6 stories above the ground, twice as wide, and thronged with buses and cars.
A great admirer of Roebling's Brooklyn Bridge, Ammann originally planned to jacket the George Washington in stone. The 604-foot towers would house an observation deck and restaurants. But shortage of money forced him to abandon that idea in favor of the square-edged 335-foot silver-colored towers we see today. Millions of white-hot rivets driven into place by pneumatic hammers hold the more than 43,000 tons of steel together.
In the beginning of the design, he felt that some masonry in the form of concrete would be necessary from an engineering standpoint. So the idea was that the steel towers would be sufficient to hold up the structure during construction, but that concrete would have to be poured on the outside layers of the steel to provide enough strength to actually support the traffic once the bridge was open. As they developed in the engineering, they discovered that even the concrete would not be necessary.
The artistic appeal of the exposed latticework, while accidental, became the most popular feature of the George Washington Bridge. After a public contest held by the Port Authority to choose a name for the bridge, George Washington won. General Washington's fortifications occupied the GWB's anchorage sites when he led the American troops against the British in the Battle for New York in the Revolutionary War. Next, the bridge that unified the boroughs of New York City. In 1885, Robert E. Odlum was the first to jump from the Brooklyn Bridge. He died 45 minutes after he was pulled from the East River. New York bridges will return on Modern Marvels. When the bridge that tied together the boroughs of Manhattan, the Bronx, and Queens over Ward's and Randall's Islands opened to traffic on July 11, 1936, it was one of the largest public works projects in the United States. In a sweltering heat wave, 200,000 citizens turned out to be the first to cross the Triborough Bridge on opening day. That it was ever completed was due in large part to the complicated and powerful Robert Moses, who in turn brought in the designer of the George Washington Bridge, Othmar Ammann.
Robert Moses was the golden boy of New York of the 1920s and 30s, even 40s. People of that generation who are still alive, they think Robert Moses is practically next to God because they felt he was the only man who could get things done.
Ironically, one day after construction on the bridge began in 1929, the stock market crashed, triggering the Great Depression, and the $5.4 million for its construction was spent even before its piers were finished. It wasn't until 1933 that construction resumed under the supervision of Robert Moses, the chairman of the new Triborough Bridge Authority. Through President Franklin Roosevelt's New Deal, Moses obtained loans and grants of $44 million on top of the $5.4 million that had already been contributed by the city.
Robert Moses, who was a great proponent of automobile traffic, recognized the need for another bridge to go from northern Manhattan to Ward's Island and then into Queens. He wanted to increase access to Long Island, where he had been installing a number of parks and beaches and recreation areas of this kind.
Both single-family homes and apartment buildings were demolished to make way for the bridge approach ramps.
They were given either a month or two notice to get out of their homes. And nobody, these were solid working class people who had invested in their homes. It was probably the largest investment of their life, and they were thrown out in a matter of seconds.
Given that Moses built bridges without factoring in public mass transit and only the middle class owned cars, people accused Moses of racism or being just plain anti-poor people. But Moses had a way of giving to the poor as well as taking away from them. So much concrete was needed to pave the Triborough's roadways that factories reopened and 5,000 unemployed men went back to work. High above the bridge, little had changed since the days of the Brooklyn Bridge. With the Triborough's main span more than 100 yards high, painters had to raise themselves up to the top by scaffolds they built using ropes and pulleys. If a man didn't fall to his death off the scaffold, he could still die of lead poisoning from the paint. Triborough's main span is a half-mile-long suspension bridge arching the well-named Hell Gate, the body of water between Ward's Island and Astoria in Queens. Within its anchorages are cables containing enough wire to travel twice around the world. Robert Caro, author of The Power Broker, a book about Robert Moses, described the Triborough as not a bridge so much as a traffic machine. With all the historical significance collectively held by the bridges of New York City, it's a surprise that 56% of the bridges operated by the city need extensive reconstruction. Over the years, the East River bridges in particular were ignored, not by the residents who marveled at their design, not by commuters dependent upon a land link to get them from here to there, but by the city of New York. In 80 years, these bridges to the past were barely maintained. The steel is still rusting on the Manhattan Bridge, and it has torsional or twisting problems. Its designer put its subway tracks on the outer edges of the bridge instead of the middle. When a loaded train comes across the Manhattan, the bridge twists toward the side on which the train is running. The bridge has been strengthened after a closing, but the problem continues. Sam Schwartz inherited that design flaw on the Manhattan as well as serious corrosion problems in the Williamsburg after he was appointed chief engineer of the Department of Transportation for the city of New York.
I inherited the bridge and I had seen all these calculations, and I called in a number of scientists who, reading these calculations, said you have a real problem. This bridge may not survive. And this is 1986, 1987, another 5 years. And there is even a probability that the bridge may not make it another day. And so I went over scenarios of what happens when a suspension bridge fails. And it is not a happy outcome. It's not as if there's warning. A suspension bridge had failed just 20 years earlier over the Ohio River, the Silver Bridge over the Ohio River. And the description of that failure was that there was a momentary shake, and then it fell right to the river with about 45 people on it who all perished.
As early as 1920, engineers noticed cable wires beginning to break and corrosion in various wires on the Williamsburg Bridge. They applied linseed oil and fish oil to stop it and then decided to wrap the wire with zinc. But the zinc next to the steel resulted in an electric potential that created more corrosion instead of alleviating the problem.
This is absolutely a crisis, and when I first witnessed this in 1988, I found situations that were even worse than this. I found a column like this that was split right down the middle, and there were many others in which were paper-thin steel, and as a result we had to close all traffic from the bridge. We had to stop the trains, stop the cars, the trucks, and even the pedestrians from walking across the bridge until we made some temporary repairs. The problem here is this cable over here, these vertical cables, along with the other suspender cables, they cradle the truss. So they're attached to each other at the bottom. That means if one major cable snaps or has a problem, both cables are useless. The scariest moment I had was in trying to learn what is the disaster mode, what happens if a cable would break. And if a cable would break, the second cable would break. That means this side of the bridge would have no support. Effectively, the roadway would tilt, and everything on it obviously would plummet into the East River.
In the redesign for the bridge, that's being corrected. So these suspender cables will be attached to the truss, independent of those suspender cables which will also be anchored into the truss. Currently, all the East River bridges share funds under a multi-billion-dollar Federal Bridge Replacement Act.
When a bridge gets to this point and the corrosion is so pervasive, you cannot save this bridge. It's unthinkable that I could just take pieces of steel. I'm not Superman, and I could just tear pieces of steel, shake them loose, and take them off the bridge. This can't be saved. It has to be replaced.
The Williamsburg Bridge, like the others, never had its expansion joints cleaned or lubricated, and so they've corroded and frozen. The structure should expand and contract with the temperature. Instead, it's pulling itself apart. Reclamation of these bridges falls to the ironworkers. The worst of it, the hard hats will tell you, is the fear of lead poisoning. Long-term exposure to the lead causes kidney disease, hypertension, stroke, nerve damage, and mental impairment.
The sheer physical demand, the hazards associated with lead exposure, the prospect of heavy objects swinging into you or falling onto you under very changeable and difficult conditions, I think requires a level of just simple bravery.
Using a pneumatic drill they call the Hell Dog to bust old rivets, workers grind and scrape away at the old paint. Workers have tracked lead-filled dust into their own homes, infecting their families. And what about the communities that live at the base of these bridges? Historically, they are the poorest citizens in New York.
No one has yet done the study to look at lead that has really come from deterioration of bridge structures to see if that gets into the community and whether that is causing elevated lead levels among especially children, because it's children who play in soil, in dust, and who put things in their mouths and with contaminated hands and toys have an opportunity to swallow lead rather than breathe it. The commonly accepted wisdom that one paint chip the size of your little fingernail, my little fingernail, would be enough to render a young child severely toxic.
Fortunately, problems of toxicity are being addressed as work continues on the East River spans. The bridges of New York City are bridges to our past as well as our future. As the 19th century architect Montgomery Schuyler said in 1883, the work which is likely to be our most durable monument and to carry some knowledge of us to the most remote posterity is a work of bare utility, not a shrine, not a fortress, not a palace, but a bridge.